You're ready.
Hi, I'm Kelsey Heaney and I'm from Cousino High School.
Hi, my name is Heaney Maurogail and I'm from Sterling Heights High School. And our presentation is going to be on cones, cylinders, and spheres. The purpose of this presentation is to present the math concept of Common Core State Standard 8.G.C.9, which is 8th grade geometry, section C, number 9, to the 8th graders for them to understand the formulas to solve the surface area and volume of cones, cylinders, and spheres. Not only will we explain to you the formulas, we will also explain how the formulas will affect you in the real world later on. Some terms to keep in mind are the radius is a straight line from the center of a sphere to the circumference. The diameter is exactly double the length of the radius. It is a straight line through the center of a circle or a sphere. And the height is the perpendicular distance from the top to the bottom of a figure. As you can see, that is the radius. Double the radius is the diameter, and that is the height. A polyhedron is also a three-dimensional figure with solid bases.
Definition of a cylinder. A cylinder is a three-dimensional geometric object. It has two flat bases being circular or elliptical. It is not a polyhedron, and it has a cross-section that is the same as the top and bottom base, which means that the circumference or the length around the object is the same throughout the whole object.
A cone is a three-dimensional figure with a vertex and a flat circular base. A cone has a curved side and is not a polyhedron.
Definition of a sphere. A sphere is a three-dimensional geometric object. It is symmetrical, it has no vertices or edges, and it is not a polyhedron.
The height of the cone is a perpendicular distance from the vertex, which is the highest point on the cone, to the center of the base.
Height of a cylinder. The height of the cylinder is the perpendicular distance from the center of the top base to the center of the bottom base.
The slant height of a cone is the distance from the vertex down to a point on the base of the cone. To find the surface area of a cone, we would need to find the surface area of a side and a surface area of the base, and then find the sum of each. To find the surface area of a side, we would multiply pi times the radius times the side, which is also the slant height. To find the surface area of the base, we would multiply pi times the radius squared, and the sum of those two would equal the total surface area of a cone. For example, a cone has a slant height of 5 centimeters and a base diameter of 4 centimeters. Find the total surface area of the cone. Here is the formula for finding the surface area of a cone. When we substitute in 2 for the radius, because we were told the diameter is 4 centimeters, 2 is half of 4, and 5 is the side's length. 10 pi centimeters squared is the surface area of the side. Pi times 2 squared is the surface area of the base, equal to 4 pi centimeters squared, and the total surface area would be the sum of the surface area of the side and the surface area of the base, which is equal to 14 pi centimeters squared.
Surface area of a cylinder. The surface area of a cylinder is 2 times pi times radius times the quantity of radius plus height. The image below. The image below shows a cylinder with a height of 4 units and a diameter of 4 units, and you plug that into the surface area of the cylinder equation. So you would plug in 2 for the radius and 4 for the height to get 24 pi units squared.
The surface area of a sphere is equal to 4 times pi times radius squared.
Volume of a cone. The volume of a cone is 1/3 times pi times radius squared times height. Example. This picture shows a cone with a height of 6 centimeters and a cone with a radius of 4 centimeters. If you plugged it into the volume of a cone equation, you would put in 4 as the radius and 6 as the height. That would solve to 32 pi centimeters cubed.
The volume of a cylinder is equal to pi times the radius squared times the height.
Volume of a sphere is 4/3 times pi times the radius cubed.
The following animation will show the relationship between the volume of a cylinder and the volume of a cone.
You have to click the animation.
This animation shows that when the radius and the height of a cone and the cylinder are the same, the volume of the cone would be 1/3 the volume of the cylinder. As you can see, the volume of the cylinder is 12 pi centimeters cubed, and the volume of the cone is 12 pi centimeters cubed, and the volume of the cylinder is 36 pi centimeters cubed. When we dilate each of the figures by 1.5, it shows the same idea. The volume of the new cone is 1.5 pi centimeters cubed, and the volume of the new cylinder is 4.5 pi centimeters cubed, which is a 1/3 ratio. Throughout the presentation, we showed you examples of how to find the surface area and volume of a figure given the height and the radius. This time we'll work backwards. Find the height of a cylinder with a diameter of 10 units and a total volume of 50 units cubed. We can substitute in 50 pi units cubed for the volume of a cylinder because it was given, and 5 for the radius because the diameter of 10 units was given. When we simplify, 50 pi units cubed is equal to pi times 25 times the height, and the height is equal to 2 units.
Real-world application. A manufacturing company is creating a new toy ball, and in order to create this ball, they have to know how much material that is needed. To find how much material, you must find the surface area of a sphere. The surface area of a sphere is 4 times pi times radius squared, and if the sphere has a diameter of 10 inches, you would plug 5, which is the radius, into the equation. So you would do 5 squared, which is 25, times 4, so you would get 100 pi inches squared. Conclusion. Throughout our presentation, we have explained the height and the slant height as well as the surface area and volume of cones, spheres, and cylinders, and we have applied it to real-world applications as well as mathematical applications.
This is our works cited page. Does anyone have any questions?